Hey guys, so I had an interesting question come in. Someone was asking about how they can optimize their scenes so that way they don't use up as much video memory when they're doing their cycles renders on GPU. So we're going to talk about that in this video, and we'll take a look at this little sample scene that I've set up and talk more about this one in particular here in a second. But for now, actually, let's go to a new document. And there's a number of things you need to keep in mind when creating 3D scenes. So first, you don't have like a scene statistics for individual objects or like an analysis tool inside of Blender. There are add-ons that add something like that. But if we take a look here under interface, you can go to status bar. You can always turn on your system and video memory. It'll show up in the bottom right. Now this is going to let you more or less just see how much resources your system's using in order to generate what's in the 3D viewport here. And so you need to monitor this as you're creating things and start to think about, what you're using, when and where. So it's going to be how you use your assets, but also like you don't need 8K textures for everything in your scene. It's not going to always improve the quality or the results of the render, right? It's about cleverly placing things and using your assets as repetitiously as possible without creating, well, repetition in the render. So anything that can be repeated and doesn't seem like it's repeated too often is worthwhile. So you can think of things like hair and fur. A lot of those things are instants, first of all, but also like distant trees. Sometimes they're just planes that are tossed together with the shape of a tree on it and scattered over a mountainside or whatever. Now, those are also instants, and a lot of times they're using like particle effect systems to do that, or geonodes, or whatever the case. Now, so instancing is a huge part of this, right? And I want to point out something here as well. Um, when you're using cycles, there's two ways you can use cycles, right? Like you can render with GPU or CPU. If you're going to render with CPU, you use your system memory. If you render with GPU, you use your VRAM. So someone was having a little bit of fun when they realized that I was using an RX 6400. So HIP for AMD and RX 6400. It's only 4 gigs of VRAM. It's a very low spec card, and it barely gets by inside of doing most 3D stuff, especially anything more complicated. But that doesn't mean you can't create amazing artwork inside of Blender with only 4 gigs of VRAM, right? It's just about how clever you are when you use your assets. There's a little way of balancing things out and making things happen. So, and it can get pretty complicated sometimes. We're not going to jump fully into this, so just keep that in mind. We're just going to be talking about some basics here. So first up, let's talk about instancing real quick. A lot of you have seen my previous video probably where I say you can hit Alt-D and create an instance like this. What does that do? It creates a link duplicate. Go into edit mode, you modify one, it modifies the other. Now these share mesh data, so these should, in theory at least, be able to save you from using more memory. Now here's the problem with this, is that as soon as you start adding modifiers to these, it breaks that instancing like behavior of it. That's just what it does. So it's not the most effective way of working necessarily. Instead, if you create an object and you place it directly in the scene center, you can actually take this object, press M, create a new collection for it, call it your asset, right? And you do something like that. Actually, let's call this just cube. So you might want to create a parent directory or parent collection. And this one you might call assets, right? You can place that collection within that collection, and then, all right, now we have that going. All right, so you can always toggle this on and off as needed. And then, but you can also now press Shift A, and you'll notice down here at the bottom, we can create collection instances. So you can see here we have collection cube, right? So I can create another one of these, and I can pull it out to the side. We can't go into edit mode with this. We don't have modifiers. We can't add a new material to this. This is set in stone, right? And so that's an actual instance, first of all. And the way this works out is that we can still modify this one and we'll modify the other one, which is great. Here's the trick. When you're going to go to render, you might have all of your scene stuff in a scene collection, right? And then so your assets you can just turn off. You don't have to see those, or you can turn them off in the render. And now if you Shift D to duplicate this or Alt D to duplicate this, it doesn't matter. It's going to stay doing exactly what it's doing. Okay. And you can go ahead and pull these out here. And you can make as many copies of this thing as you want. And until you run out of VRAM or system memory, you won't have any issues with it, right? And you could go absolutely insane with this. And that's why I made that example scene back there that we'll take a look at here in just a moment. So this is going to be one of your best ways of saving performance. Now, anything you can recycle though, any kind of texture, I'm talking about just the individual texture, not even a material. Uh, if you can recycle those things over and over and over again, you're going to save memory. And that's really what you should be doing, thinking about using as many things that will create an instance-like behavior, such as like mirror modifiers or arrays, but also doing this here with the actual placement of things using collection instances. So now materials are a little bit more complicated. I'm just going to talk about it real quick. But you can create base materials off of black and white images. And this is why I released those grunge maps some time ago. Is that if you want to take a black and white image that's a seamless texture, you can start turning it into all kinds of different things. And what you can do is you can, because a black and white image only needs to occupy one channel of a red, green, and blue image, right? You can pack 3 of those into a single image, and you can bring in lots and lots of grunge maps with very little cost, just a few images, right? Red, green, and blue images anyways. And so if you can learn about channel packing, that's hugely important for optimizing your textures. But also you can take those textures, those base textures that you would make materials out of, you can also blend materials together, and you can use what's called RGB mask, which is still just texture packing. Instead of having grunge maps in the red, green, and blue channel, you have mask in the red, green, and blue channel. And then you can use those to blend on objects. So if you wanted to, you could make unique looking objects with their own texture mask, but they use the same base materials. Think of like a factory, and you're putting a whole factory scene together. There's a bunch of rusted parts in there. You may need like a bare metal, rust. You can start layering those together here inside of Blender. You can break them up with really low resolution and RGB masks, and then you can use things like grunge maps to break up how that actually blends together based off of those RGB masks. And it's way out of the, we're going way out there with that in this one. Just talking about it, I don't have the time to show in this one video all of that, but it can get pretty complicated, right? So you'll want to look into layer blending, right? Material blending, if you want to think of it like that, or material masking, whatever. There's all kinds of different names for RGB masks. And start thinking about that kind of stuff, okay? Now, let's go back to my scene. I want to explain why I even made this thing, first of all. So first, this is set right now to render on GPU with cycles, right? And so if we take a look at render preview, it's going to look something like so. It's nothing real special, but I think you get the idea here. It's doing this, right? So we got a HDRI, just a generic water, and some rocks that I quickly sculpted, and some little cylindrical things that I placed out here. Let's imagine this for a second as like a big scene you're going to animate or something, right? You have like thousands and thousands of like penguins hanging out on an iceberg or something like that, right? And they all maybe need to be a little bit animated or something, but let's just say something like this is going on, right? Or you just want to do a still render. Anyways, so here's the thing. If we go back to solid, we take a look at one of these guys here. Actually, we got to look at the original asset because those are collection instances, right? So we're going to take a look at the original asset, turn those off for a second so I can hopefully find these things. Right. Okay, so we'll take a look at the rock first, I guess, because it's in here, / and isolate it. And the rock here doesn't look like much right now. It was quickly sculpted, and then I used the actual quad remesh that comes with Blender, which is under it's under remesh and quadraflow, right? Well, it generates a decent quad mesh that you can continue to sculpt on with multi-res if you needed to, especially for more organic stuff and natural stuff anyways. But you can see here, it doesn't look all that special until you realize there's other little tricks to make the full use out of your models as well, such as use a multi-res modifier. So you can continue to detail this thing and sculpt on it, but in the viewport here, we can preview it at a level of 0, right? And so we could preview it at 0, but if we go into sculpt mode and we start working on this thing, you'll see that it is actually really dense, right? It's got some noise and stuff tossed onto it, okay? But on top of that, we could do even more things to this potentially. We can use displacement maps, right? So this actually has a material, and in that material, I'm just applying a noise texture to a displacement and feed it in here. You have to set options, of course, to displace right under the settings. So when this renders, it's actually going to displace as well. It's not going to show up in the viewport, but it'll be there when it renders. Now, so that's just the rock, right? And how many faces is this thing, right? That's the main question. So this one in particular, we're at 859,000 faces. It's pretty dense. Okay? So let's get out of that. Let's take a look at the little cylinder, which is actually more dense. And there's a lot more of them. So we take a look at this one. I didn't sculpt on it or anything, but it does have a multi-res on it. This object is 1.7 million faces, so it's pretty heavy, and it's just an example of what's possible, at least. And so now when we back this whole scene out, and we view through the camera, and I said, oh, we turned the collection off. I was like, why is nothing there? Anyways, if I wanted to render anywhere, right, we're doing a cycles GPU render, right? And I hit F12. This is on my RX 6400, right? It's not a very powerful card at all. Very slow. And so it's good for stills. It's not good for animation, definitely. But you can see what's happening here. It is, in fact, well, it's rendering it. How's this possible, right? There's a lot of stuff here that's very high polygon count. Well, they're instances, so it's not taxing it at all, hardly. Look at the memory usage here, the peak of it. It's 1,763 megabytes. So I've used about maybe like a quarter almost of my memory, right? And so I think you get the idea there. It's possible to do this kind of thing, right? Now, the HDRI image itself is also very heavy, right? So if I was to use a simpler HDRI and I could get away with that, well, I could. And let's see what this one weighs in at. We render with this one. This might be a 4K one. Yeah, this is a 4K HDRI. It's much, much lower memory usage. So we're well below 1,000 here, right? And you can see it changes the scene dramatically as well. So you can actually make artistic choices and clever use of certain different assets, whether it's an HDRI, a texture, does it need to be 8K, or can you get away with a 256 by 256 image, right? You need the absolute 16K HDRI, or can you get away with a 4K? You see where I'm getting at with this? Can you use an object repetitiously over and over and over again in the background or wherever, perhaps, even if you need a lot of detail on it? Maybe you could possibly do that. So even with 4 gigs of memory, you should be able to push out some really high quality stuff. And the simpler you keep things, the better. You'll notice like the water here, for example, is first of all, it's just a noise texture hooked up. Oh, that's not the one. Yep, we had it. Come back. It's just a noise texture hooked up and mixed with another noise texture, put into a bump mode or bump node, and roughness dropped and metallic up. So it's really just a simple material. There's nothing crazy going on here. This adds very little to the overhead. The volumes here for fog, I just threw a couple in real quick. Nothing special either. They hardly use any memory, so they're not too bad. And the water itself is just a plane with that simple texture. Underneath the water, there's another volume, so that it looks like it has some depth to it. And then there's another one for like the sea floor, if you would. Another plane anyways. So if you can keep geometry simpler, if you can reuse geometry, if you can reuse textures, and it all starts to add together, right? Like all of this combined together is how you end up with really clever looking, good looking 3D renders, basically. So whenever you're worried about not having like the best PC or the best video card, don't let that stop you. All right, there's definitely ways you can get around certain limitations, and they're mostly going to be pulled back into like artistic choice and scene composition and things like that. But you definitely can do it, and that's what this video was really about. I just wanted to talk about these kinds of things. So now, if we really want to have a good, fun little idea here, if we were to grab one of those objects, press Shift L, we can select by instance collection. You can see that's all the objects. I have 4,704 objects, so let's just do a little math here. We knew that this was 1.7 million on each on that original object anyways. And so if we were to take this and let's just multiply it by what we have in the scene, 4,704, we're looking at well over 7 billion, right? Represented faces. That's crazy, right? Like on GPU rendering with a low spec video card, you can get away with madness, guys, if you really wanted to. On the flip side of this, also, if your GPU still just doesn't compute this stuff, but you have a decent CPU and you got a lot of system memory, I have 64 gigs of system memory. Hey, you can render on system memory all day long as well. It's going to be slower, sure, but it's not going to stop you, right? If you need that extra that extra memory usage, you can always use more system memory or CPU. You don't have to always render on the GPU. It's just what everybody seems to hype up a little bit. So if you're doing stills and it's a slow CPU render, who cares? It doesn't matter. As long as it doesn't take, like a month to render an entire animation, you'll probably be okay, right? Other than that, it's really it for this video. I mean, I just wanted to point all this out to you guys. There's not really excuses for not creating great looking 3D, right? Unless you're just not doing it, basically, is what I'm trying to point out. So you make full use of your tools, your assets. You make full use of your system. If you got to go to CPU, use CPU. Use GPU if you got to use GPU, or you want to use GPU anyway. And then create good work. That's it. That's all. That's the secret to 3D. Putting in the time, the effort to make everything you make look good, and just paying attention that you're not overdoing things you don't need to overdo, basically. As far as render settings go, I know I didn't talk about this because they're really not as important as you think. You can pretty much use the default settings. It's not going to change too much, but you can speed it up or slow it down with some of the render settings. But you can improve quality or reduce quality as well. But ultimately, I don't know if that's like, it's good to look into the basics with that, but they're not as important as you probably think they are in a lot of ways, anyways. So don't get too caught up in this idea that there's like some special sauce for render settings. Like there's some things that help, but Cycles is pretty basic. It's not like you're gonna, there's not gonna get like, once you start learning it, you'll understand like there's only so much you can do with it, and then the rest goes down to like compositing, which you can do more. But there's only so much you can tweak here. So, and it's relatively straightforward and simple. Doesn't change the results too dramatically, I would say, but it can speed up your renders quite a bit as well if you lower the quality, obviously, or use like fast global illumination. I usually just use the drop downs like lower memory usage, and then let's do limited global illumination or fast GI, and usually that'll speed you up as well, which I don't know if I had those on for this scene or not, but usually it speeds it up a bit. And it virtually looks almost identical, but you could do tests and compare and all that. So, yeah, so anyways, that's all I wanted to talk about for this video. I hope you enjoyed and you learned a little bit of something, or at least you have some things to look into now, so that when you're working on your scenes, you're thinking of these things. You want to make sure that you're paying attention to that memory usage and you're trying to utilize all of your assets as efficiently as possible. Okay. Anyways, with that in mind, or all that stuff I just put out there, do look into it further. All right. And you'll definitely grow as an artist because of this information. So hope you enjoyed it. I'll check you out in the next one. All right.